The theory of relativity is one of the most important and revolutionary scientific concepts of the 20th century, developed by the physicist Albert Einstein. The theory challenged the classical understanding of space and time, and proposed a new way of thinking about the fundamental principles of the universe. The theory of relativity is based on two main principles. The first principle is that the laws of physics are the same for all observers, regardless of their motion. This principle is known as the principle of relativity. The second principle is that the speed of light is always the same, regardless of the motion of the observer or the source of the light. These two principles led Einstein to propose a new understanding of space and time. According to the theory of relativity, space and time are not separate and distinct, but are instead woven together into a four-dimensional fabric known as space-time. This fabric is curved and distorted by the presence of matter and energy, and determines the way that objects move through space and time. The theory of relativity has two main components: the special theory of relativity and the general theory of relativity. The special theory of relativity was developed first, in 1905, and deals with the behavior of objects moving at constant speeds. The general theory of relativity was developed later, in 1915, and deals with the behavior of objects in the presence of gravity. The special theory of relativity is based on the idea that the speed of light is always the same, regardless of the motion of the observer or the source of the light. This means that time and space are not fixed and absolute, but are relative to the observer. The theory also introduced the concept of time dilation, which means that time appears to pass more slowly for objects that are moving at high speeds. The general theory of relativity builds on the special theory of relativity, and introduces the concept of gravity. According to the theory, gravity is not a force that pulls objects towards each other, but is instead the result of the curvature of spacetime caused by the presence of matter and energy. This means that objects with mass distort the fabric of spacetime, causing other objects to move towards them. One of the most famous predictions of the theory of relativity is the equation E equals mc squared, which states that mass and energy are equivalent and interchangeable. This means that a small amount of mass can be converted into a large amount of energy, and vice versa. This equation has had significant practical applications, including the development of nuclear energy and weapons. The theory of relativity has had a profound impact on our understanding of the universe and the way that it operates. It has challenged long-held assumptions about space and time, and has led to the development of new technologies and scientific fields. The theory has also had a significant cultural impact, inspiring works of art, literature, and music. Despite its importance, the theory of relativity remains one of the most difficult and complex concepts in science. It requires a deep understanding of advanced mathematics and physics, and has been the subject of much debate and discussion among scientists and scholars. Nonetheless, the theory of relativity remains a cornerstone of modern physics, and will continue to shape our understanding of the universe for generations to come.